We tend to think of the ground beneath our feet as an absolute guarantee, a permanent fortress of solid rock, and deep, steady oceans that will always be here. But that stability relies entirely on our precise distance from the sun. We exist inside a narrow safety ring, the Goldilocks zone, allowing for a liquid-rich, rocky world. If that balance breaks, gravity begins pulling the planet continuously inward, dragging it out of the safety zone. You might imagine a decaying orbit ends with the Earth simply colliding with the sun like a meteor. Instead, the relentless increase in extreme heat dismantles the physical structure of the world long before impact. Moving closer to the host star triggers a catastrophic phase change for the entire planet. The first noticeable warnings happen right above our heads. The atmosphere reacts to the intense radiation, altering how light scatters, and turning our familiar blue sky into stark, vivid shades of orange and red. Down on the surface, ambient temperatures spikes far beyond normal extremes. Global cooling systems are overwhelmed, and technology begins to fail as the heat rises. These atmospheric shifts are the final warning signs before the global ecosystem breaks down. As Earth breaches the inner boundary of the solar system, it faces the unshielded force of extreme thermodynamics. The relentless barrage of solar radiation strips away the gases that insulate us. The atmosphere fizzles out into space, leaving the surface naked to the incoming energy. With the pressure dropping and temperatures soaring, the hydrosphere undergoes an immediate phase change. The oceans hit their boiling point, churning violently as miles of deep water convert into thick, choking steam. Without its air and water, Earth is reduced to a naked, hyperheating rock. This photographic view of the sun reveals the environment the planet is entering, a landscape of intense, glowing plasma, where temperatures exceed 5,500 degrees Celsius. Before the ground even gives way, the human footprint in orbit is erased. High-altitude metallic objects, from small satellites to entire space stations, liquefy. But the heat is only half the problem. As Earth gets closer, uneven tidal forces from the encroaching star create enormous gravitational shear, pulling at the structural integrity of the globe. The immense tectonic stress snaps the outer crust. Global-scale fissures tear open, exposing the deep interior as the surface fractures. This leads to a geological collapse. The sheer ambient heat and friction cause rock to flow like liquid, and mountain ranges literally melt away. The definition of a solid planet has been erased. The world is now a structurally failing molten mass. Finally, the molten remains reach the edge of the star, entering an environment of crushing pressure and a complete absence of oxygen. Even the Earth's longtime orbital companion is lost. In this image of the Moon, the Sun's overwhelming gravity overpowers Earth's pull, casting it adrift. For the Earth, the final moments are violent. Fiery arms of plasma and massive solar flares reach out, enveloping the liquid globe. The core and remaining rock undergo vaporization, puffing outward into a cloud of glowing gas and burning debris. No wreckage remains, only an atomic reassimilation into the star. The local space falls silent. What was a complex, bustling world just hours prior is now an empty void. This timeline reveals a sobering cosmic truth. Planetary bodies are temporary collections of matter, existing at the mercy of their host stars. Currently, Earth remains secure in its orbit, situated safely millions of miles away from the sun's destructive plasma. The solid ground beneath our feet rests on the quiet, invisible balance of orbital physics.